Hello everyone, today I will talk about my project. It's fake news detection with machine learning models. Firstly, I collect datasets from Kaggle. These are fake and true CSV files. I load them to Colab and I display them. Fake news, display first fake news dataset and display first 5 rows of true news datasets. And I added the class labels 0 for fake news, 1 for true news. I check data set shapes, so that means I have total approximately 40,000 data sets. Manual testing for data sets. I removed last 10 rows for manual testing. I save it when I set and I add class labels, and I save it as manual testing CSV file that gonna use to test models prediction later. I merged both data sets. I merged remaining rows. It's gonna use for training and validation. I drop unnecessary columns, title, subject and dates. I removed them. I checked missing values. There's no missing values. I shuffling dataset and reset index. I shuffling them and reset index. Text cleaning function. Text cleaning function. We did preparation. Now text preprocessing. This preprocessing reduce noise in data and make it easier for model to focus on relevant question. I convert text to lowercase. I remove content inside square brackets. Remove URLs. This preprocessing reduces noise in data and make it easier for model to focus on relevant features. I split data into training, validation, and test sets. Training set is 70% of data, validation 50% of data, and test 15% of data. I use Stratified to maintain the class distribution across splits. Feature extraction. I extracted the top 1000 frequent terms. I removed stop words to improve model focus. And machine learning algorithms. I trained 4 different machine learning models and evaluated their performance. First of all, logistic regression. As we see, logistic regression model showed good overall performance. However, the test accuracy was slightly lower than other models, suggesting some room for improvement in handling complex patterns in data. And I displayed their loss classification reports and confusion matrix. Second one, decision tree. As we see, decision tree model performed excellently on the training data but suffered from overfitting. This was evident as its accuracy on the test sets was significantly lower compared to its training accuracy. And I also displayed their loss classification report and confusion matrix. Third one, random forest. As we see, random forest, it's achieved the highest test accuracy of 99.66%, make it the best performing model in this project. Its ability to generalize well on unseen data made it excellent choice. And I also displayed loss classification report and confusion matrix. Final one, gradient boosting. Gradient boosting performed almost as well as random forest, demonstrating strong accuracy across all datasets. And also I displayed loss, classification report, and confusion metrics. Now performance comparison. To better understand the results, I created a comparison table inspired by the format in Chapter 8, Section 2 of Classroom Slides. This table detailed the accuracy loss for each model, helping to highlight the strengths and weakness of each approach. Now, model testing. I displayed first text entry for each class for fake news and true news. Now I'm gonna test it and I'm gonna show how it works. Firstly, I copied fake news, one of the fake news, and paste it and get the results. It's fakes. Yes, that's true. Now for true news prediction, copy it and paste it. For true news, copy and paste, and true news, as we see, it works very well. So now what I learned this project, the importance of data preprocessing and cleaning in improving model performance, and how different machine learning algorithms perform on the same task. First, logistic regression, balanced but slightly lower test accuracy. Second one, decision tree, prone to overfitting. Third one, random forest, best test accuracy and robustness. And last one, gradient boosting, close performance to random forest. Ultimately, the random forest model proved the most effective for detecting fake news in these datasets, achieving in highest accuracy and demonstrating strong generalizations capabilities. So, thank you for listening to me.